8.2, we're going to look at different types of chemical reactions. So the first type of a chemical reaction is the synthesis reaction. So synthesize means to make. So with a synthesis reaction, we're going to be making one new substance. So you'll start out with two or more substances, and they're going to all combine together to make one new substance. So here, as an example, the general formula would be substance A plus substance X producing a compound AX. Salt is an example of a synthesis reaction. So you have sodium and you have chlorine, and those combine to make sodium chloride or salt. And so let's look at this clip so you can see how this actually happens.
Sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
And that is a simple reaction to make salt. The next type of reaction is the opposite. It is a decomposition reaction, so you're decomposing something or you're breaking it down. So you're going to have a single compound. So for example, here we have AX, and that's going to break down into two or more substances. So AX is going to produce A and X. An example of this would be when you have water and you're breaking that down into the hydrogen and oxygen. Electrolysis is a decomposition reaction that you use electricity to separate the items that make up that compound. So you can see a picture of the setup, and we'll look at this video as well. So in this, they're going to use just a simple 9-volt battery to create the electricity. So what he's done is he's placed some tacks on there, and the electricity is flowing through the water, and you can see it's creating bubbles, and those bubbles are actually the hydrogen gas and the oxygen gas that's produced. In one tube, it's going to have the oxygen go, and then the other tube will have the hydrogen. Now, H2O is made of 2 hydrogens for every 1 oxygen. And if you can see up at the top, let's see if I can find that part in the video. There we go. You can see here, this has twice as much as the other, much gas in here. So this is the one with the hydrogen because there's twice as much as opposed to the one with the oxygen. The next type we have is a single replacement reaction. In a single replacement reaction, you're going to have a simple element combined with a compound. So here we have A would be the element by itself combined with the compound BX. That element that's by itself is going to swap places with something that is in the compound. Now let's say that the element that's by itself would make a positively charged ion. Well, then it's going to swap places with whatever element in the compound is also positive. If that element that's by itself would make a negative ion, then it will swap places with the element in the compound that's negative. So you have to determine what type of ion your element by itself is going to make to know who it's going to switch places with. So let's try a couple of these. So first of all, we have aluminum. Aluminum, if you were to look on the periodic table, forms a +3 charge. So we know it's going to swap places with the positive ion in our compound. So the first thing that we have to do is determine what are the charges of the ions in the compound. And we can use the crisscross method to determine that. So if we had crisscrossed down our charges, that means that the lead, the Pb, would have been a +2 because this 2 would have come from here. And then this understood 1 would tell us that the NO3 is a -1. So like charges are going to swap. So Pb will be out by itself. And then we will have aluminum combining with the NO3. And then we would swap, we would crisscross those. So if aluminum was +3, we need a 3 outside of the parentheses. And if NO3 was -1, then that means down here would have an understood 1. What about Na plus water? Water is kind of special. We're used to writing it as H2O, but when you're doing these reactions, you need to keep in mind that it actually will separate so that it's H combining with hydroxide. So if we look at it this way, sodium forms a +1 charge, hydrogen is +1, and hydroxide, if you look on your polyatomic chart, is -1. So the Na is going to swap places with the single H. So that H would be out by itself plus the Na combining with the OH. Let me fix that here. OH. Now, one thing to look at when we write this part of the formula, Na was +1 and OH was -1, so that's correct. Now the element by itself, is it diatomic? And remember, those that are diatomic are hydrogen, nitrogen, oxygen, and all of group 17. Hydrogen is diatomic, so when we write it in the formula, we have to write H2 when it's not in a compound. Let's look at the next one. Mg is a +2, H is +1, and chlorine is -1. So these will switch. So hydrogen out by itself, and again, it's diatomic, so we're going to write H2 plus Mg, and that goes with the chlorine. Now Mg was a +2, so we need to cross down a 2 there. Cl is a -1, so we are finished. So these are single replacement reactions. Let's look at the next type. Now we have double replacement reactions. In a double replacement reaction, you're going to have two compounds. And so, for example, we have AX and BY. The positives from each compound are going to swap places. And remember, the first element listed in your compound should always be your cation. So the first two are going to switch places. And instead of AX plus BY, now we have AY plus BX. Most of the time, these are going to form a precipitate, which is where we get that cloudy solid that is produced when you have two liquids mixed, a gas, or water. So if we have NaCl plus KBr, then the Na and the K would swap places, and we would get NaBr plus KCl. Or if you have Justin and Selena, and back in the day, Taylor and Taylor, they did a little swapping around. So now we're going to write some double replacement reactions. So all of these we're going to break down into their ions first. So Na is +1, chlorine is -1. Then Ag, if we look that up, it says +1, and NO3 is also -1. So we're going to swap our positives. So we'll put Ag with the Cl, and those were both 1s, so we don't have to worry about crisscrossing, plus, and now the Na with the NO3. And those were both 1s. So again, we don't have to worry about the crisscross. What about the next one? We've got Ba and Cl2. Ba is a +2, and Cl is a -1. Mg is +2, and SO4 is -2. So we're going to swap the Ba and the Mg. So now Mg will be with Cl, but Mg's a 2 and chlorine's a 1. So we need to bring down the 2 there. Plus, now we'll have our Ba with our SO4. So Ba, SO4. And since both of those are 2, if we crisscrossed, we'd have a 2-to-2 ratio, and those would cancel to 1-to-1. Let's look at the next one. H is +1. Cl is -1. NaOH, OH is hydroxide. So Na is +1, hydroxide is -1. So Na and hydrogen will swap places. So we'll have Na with Cl. And remember, always put your positive one first when you're writing these. And so Na and Cl were both 1s-to-1, so we don't have to worry about crisscross. Plus our hydrogen with our OH, and that's a 1-to-1. And you can leave it like this, or if you notice HOH, we said earlier, is another way to write H2O. Either way that you want to write that is fine. So these are double replacement reactions. The next type is a combustion reaction. Combustion reactions are always going to involve oxygen and some type of carbon fuel, basically, a hydrocarbon fuel. So if you look at all of these, we have hydrogen, and that's going to be used to burn, and all of them have some form of carbon and hydrogen combined together. And most of your fuels that you burn in your car or your house are all going to be some type of hydrocarbon. These all are always going to produce water and carbon dioxide. So if you have a reaction and you're wondering what type it is, if you see a reactant that is oxygen, products are water and carbon dioxide, that tells you it's a combustion reaction. So the next couple slides, we're going to be given a reaction. We have to determine what type of reaction we have. So here we have a chemist mixes lead 2 nitrate. Now lead 2 nitrate, that's not just a simple element, it's a compound. So we're going to say compound. And potassium iodide. So again, a compound. Both are clear liquids. We get a yellow precipitate in the final solution. So that means if we've got a solution and a yellow precipitate, so we've got a liquid and a precipitate is a solid. We've got two different things there that we've made. The remaining liquid is an ionic solution. Solid precipitates containing lead are yellow. So what we have, two compounds produce two compounds. So this tells me this has to be something that's like AX plus BY, making two different compounds. So it would be BX plus AY, or a double replacement reaction. Magnesium metal, so we can go ahead and kind of note that. Magnesium is placed in sulfuric acid. And sulfuric acid is a compound, so that's going to be H2SO4. But you really don't need to know that. You just need to know it's a compound. It begins to bubble. Bubble means I've got a gas produced and a liquid. So if I have a single element and a compound, that's going to tell me that I probably have either a single replacement or a synthesis. Now, how do I determine that? How do I determine which one? So because I have a gas and a liquid, it's not synthesis because synthesis is only going to make one product. So this has to be single replacement. A student heats barium metal. So that's just barium. So Ba. We heat that. It begins to react with the oxygen gas in the air. So plus O2. A white crystalline solid begins to form on the barium. So we're making some solid. So in this case, we've only made one thing. So this would be a synthesis because we have two substances making one final product. So this would be a synthesis reaction. We have water placed in an electrolysis machine. The water is placed in the machine and it begins to bubble. And we saw this example earlier. So we've got H2O. Oh no, go back. Let's see. H2O. And we get bubbles. So we know that that's going to break down into hydrogen plus oxygen. And it tells us that they have put glowing splints in the gases. And so that's confirming that we've got hydrogen gas that is flammable. So one substance breaks down into two. This is a decomposition reaction.